Hello guys, and welcome to Matters, Mixtures, and Separation in the Science 8 Mix and Flow of Matter unit. Let's begin. Particle model of matter is an important part of mix and flow of matter. There are quite simple rules there, like the particle model of matter. It's quite simple if you think about it. It's like all of these basically. All matter is made up of tiny particles. Particles have spaces between them. Particles are always in motion. There's a difference in movement between solids, liquids, and gases, and I'm pretty sure everybody knows what a liquid, solid, and a gas is, right? Gases have more spaces in between them than any other substance or anything, right? And then next comes liquids and then solids. The particles in solids are really close together. That's why they're solid, right? Okay. As temperature increases, so does motion. And as temperature decreases, so does motion. Next slide. Properties of matter. Properties are characteristics we can use to describe matter. Properties can be qualitative or quantitative. Well, some descriptions of qualitative would be some examples, would be color, state, texture, luster. And then some examples of quantitative would be boiling point, melting point, solubility, and density. All matter can be classified into two different categories, which can also be classified into different categories. All matter can be classified into two categories, pure substances and mixtures. Pure substances also goes off into two different, which is elements and compounds. Elements will always have particles that are the same, and a compound is a combination of elements. And then mixtures, on the other hand, is completely different. Homogeneous, which is one of mixtures, one of the branches that goes down. Homogeneous are materials that are mixed in such a way that it looks like one material. So it's two materials or more that you mix together that looks just like one. So some examples of an homogeneous mixture could be potentially orange juice, some orange juice, right? Then heterogeneous mixtures are two or more mixtures that can be seen, like salsa, which is made up of different ingredients and stuff like that. And also even if I'm not wrong, 7-Up can also be like that. You can see the gas bubble that is created, which is also one of the different mixtures used to create it. So pure substance contain only one type of particle, can exist in three states of matter. Each pure substance has its own set of physical properties. Mixtures, a combination of two or more pure substances. The properties of each one are not lost, but are eaten, but might be eaten, right? Like over there, right? That's you can't really see anything there. But over here, you can just tell. You can see some green, then some brown and white. You can just tell it's all mixed over. But over on here, you can't see anything. So this would be an example of an homogeneous mixture right here, and this would be an heterogeneous mixture. Two types of mixture, yep. Particles of different substances are easily seen and distinguished from each other. Like I told you before, they may contain equal parts or not equal. Like blood, it looks red, but it has more than one thing in it, right? Like over here too. Sometimes you can see the different things in blood too, right? Homogeneous, also known as solutions, appear to be one substance but is not actually one. Particles of different substance are intertwined. Every sample of the mixture will contain equal of all matter that make it up. So, making a solution. To make a solution, which is also an homogeneous, it's quite simple. You need a solute and a solvent. So, for the examples over here, take a sugar cube and drop it into a glass of water. Then the water is, come on, the water is the solvent. and then the sugar is the solid. So what makes it dissolvable? It's quite simple. The particles attract sugar particles, like water particles. They basically call on the sugar particles more than the sugar calls on each other, right? So it's kind of like trying new things, right? When we call them opposites, the water calls on the sugar, and the sugar also calls on water. Not as much sugar particles call on sugar, right? So then the water and the sugar go together and they get dissolved because the sugar particles get caught up behind and all around the water particles and is hidden by the water particles, which is what is called dissolving. So degree of attraction depends on solid and solvent. Yeah, salt can also be a solid, right? But it's not as great as sugar for water, right? But water being the solvent, right? If a substance is soluble, it means that it is able to be dissolved in a certain solvent. Like sugar can be dissolved in water, right? And yeah, things like that. Solubility is the mass of a solute that can dissolve in a certain amount of solvent at a certain temperature to form a saturated solution. Particle model again. Particles have spaces between them. In order for the solutes to hide in between particles, there need to be spaces. Like I said before, the water particles kind of cover the sugar, so the sugar particles are hidden, right? Particles are attracted to each other, right? Yes, they are. Sugar is attracted to water more than the other sugar particles, right? Like it says over there, they must be attracted to each other. Particles are always in motion. In order for the solid to get between the solvent, they have to, yeah, in order for the solid to get between the particles of the solvent, the particles have to be moving, right? Because if you're not moving, they'll just stand there and not really do anything. So, yeah. Types of solutions is unsaturated, a saturated, and a supersaturated. Unsaturated is when more solute can still be dissolved, so you can keep adding more sugar and they're still dissolved. Saturated is when no more solute can be added at that temperature. We're going to look more into temperature a bit later. And then more solute is dissolvable that should normally be able to be dissolved, then should normally be able to be dissolved in the solvent at that temperature. So when like a lot more than normal is dissolvable, right? After supersaturated. Factors that influence solubility. This means stirring, shaking, yeah. Okay, moves particles around and makes room for more solid particles in between solvent. That's one of them. Surface area is also another one. If it's a bigger area, it's like tends to go around more, right? Breaking up the solvent means more particles exposed to the solvent, easier for solvent particles to surround the solute, right? And then there's temperature, the key aspect. Because when, like in the particle model of matter, as I said previously, when temperature increases, the spaces in between increase too. So, like, let's say a liquid or like water, when you increase the temperature, the space in between increases. So when you add more sugar, since there's more space, there's more room, and it's more able to be hidden, causing it to more space to be dissolved, right? Then there's pressure, last but not least, which increase the solubility of gases under pressure. Gases. What do we need to know to be able to separate a mixture? We need to know the properties of the components of the mixture and how they differ from each other. Example, solubility state. Separation methods take advantage of differences in properties. And one of the ways is filtering, believe it or not. Filtering, right? So you could technically filter water and water and rice. You can filter that, right? Like everybody knows that, I'm pretty sure. So separates, filter and separates an insoluble solid from a liquid, right? If it's soluble, it would have dissolved, so it won't really be possible to do, right? So suspensions can be filtered, solutions cannot be filtered. Suspensions can be filtered, solutions cannot be filtered. And in case you guys don't know what a suspension is, it's basically an heterogeneous mixture, right? So it's not mixed together like a solution. So yeah. That's what a suspension is. Then desalination of water. D is to take out. Saline, obviously, as in the name, contains salt. Fresh water is very important. Not everywhere. There's not fresh water and everywhere. In like a lot of the human body is covered in water, so you need water. So there are huge desalination plants operated in some parts of the world to make seawater drinkable, but they require a lot of energy and are quite expensive to run, right? So there's the dessert tank method. It's slow but effective for desalinating small quantities of salt water. So basically, as you see over here, there's the sun, and then clear glass or plastic to transmit radiation. Then there's just water on a brine basin. So they have a roof, a glass roof, like I said, clear glass or plastic. So the sun heats up the water, and it evaporates, correct? Let me correct myself. It evaporates and goes up, as you can see, and then condenses when it touches the glass, and then it trickles down the side into a collection of condensate, right? And then, yeah, and then the salt or whatever has been filtered is just left at the bottom. So incoming radiation energy 2, 3, and 4. Okay. Evaporation takes advantage of difference in rate and temperature of evaporation. Eats up mixture until the solvent evaporates. You'll be left with the solid, like in the dessert tent method. You eat up the water and you have the salt left, and you still have the water if you collect it right. This method does not allow us to recover the solvent, which is why they invented the dessert tent method. They put the clear plastic glass on top, so it'll instead of just floating up into the sky and creating clouds or something like that, it'll hit off the cold glass, which would cause it to turn back into water and trickle down and go into a bowl or basin, right? But most of the time, evaporation, you only left with the solute. So the solvent just floats up into the sky. Distillation allows us to collect both the solvent and solute, which is why the dessert tent method is distillation, right? Different fractions or components of the mixtures are separated and collected in different containers. Takes advantage of different boiling points of substances. So here, as you can see, here's salt water heat applied from the bottom. It evaporates and goes to the top and then goes through here and is collected here. So the solute will remain here, right? The salt or whatever, oops, my bad. The salt or whatever will remain right here. All the water will come over here. So you can separate the water and the salt to get drinking water, right? The density. You guys might not know what density is, but I think it'd be useful for you to know it for my next YouTube video, which will be covering density, buoyancy, and viscosity mostly. So density is how packed, or in another word, thick an object or substance is. Density is also how close the particles are, which means it is also affected by temperature, right? Because temperature, it heats up, goes farther, like in the particle model of matter in previous slide. I will be putting this slide up, and I'll put a link to this slide, and you don't have to sign in or anything. You already have full access to it, so don't worry about that. And I will keep adding more onto the slide for future purposes, right? So, and viscosity is almost like density in a way, because it's how thick a fluid is and how fast it flows, right? And we also need, since we're talking about viscosity, we need to discuss internal friction. So it's when there's more internal friction, there's less viscosity. Because if you think about it like this, let's pretend that there's some people, let's say you're trying to go through a hallway, then people have their legs they have their hands and feet up and down, right? You're gonna be slowed down, obviously. Let's pretend the more those people are in internal friction at zero viscosity. You just keep going. When there's less people, you can go faster. When there's more people, it becomes packed and kind of harder to move around, right? Okay, so thank you for watching. Have a blessed day. I'm gonna put all the links in the description. This is edited with Smart Pixel. You can now use it and welcome you to try. Have a good day.